everybody, to the School of International Service at American University. My name is Simon Nicholson. I'm director of the Global Environmental Politics program here in the school, and I'm also co-director and co-founder with Michael Thompson, who's here in the room, and another colleague of something called the Forum for Climate Engineering Assessment, which is a scholarly initiative we have here in the school, which is looking at the climate engineering conversation and is looking to make it more inclusive and robust. This is the second in a fall speaker series that the Forum has put together. Let me say just a couple of words and then I'll introduce our speaker. The speaker series is designed to make sure that we're hearing from a wide array of voices on questions related to climate engineering. And as an emerging topic, there is some context which people need to understand before you can understand the nuances of the conversation. And so we've asked our speaker to help kind of set up the conversation that he'll spark today by giving us just some background information on what climate engineering is and why it's important to be paying attention to it. So we're joined today by good friend and colleague David Grover-Morrow. David Morrow is a visiting fellow at the Institute for Philosophy and Public Policy at George Mason University and also a faculty fellow attached to the School of International Service through the Forum. He studies philosophical and policy issues surrounding climate justice and has written a string of provocative and interesting papers on the ethics and governance of climate engineering. Welcome.
Thanks, Simon. Thanks to all of you for coming. All right. At a conference last summer on climate engineering, a friend of mine offered the following confession. Every morning I wake up, he said, and I tell myself, this is crazy. Why are we even thinking about climate engineering? But, he went on, by the end of each day, I catch myself thinking, maybe this is worth considering. I want to explain to you today why I think my friend was right when he woke up in the morning saying that it is crazy to even be thinking about a particular kind of climate engineering known as solar radiation management. But I also want to explain to you why I think he was right in the evening when he said that it was worth considering. In other words, I want to explain why I have come to believe that though there are powerful arguments against doing research into solar radiation management, further research into solar radiation management, including limited outdoor research, which has so far not been done, is morally permissible. I should say right away that the views I'll express here are my own. They do not represent the position of the Forum for Climate Engineering Assessment or anyone else associated with it. As Simon said, the goal of the Forum is to promote wider, thoughtful, well-informed public discussion of climate engineering, and that means not trying to direct it to any particular outcome. For the last several years, my own academic work has shared that aim, trying to analyze and evaluate various arguments for and against different kinds of climate engineering. But today I want to go a step further and try to draw a substantive conclusion from those years of reflection. So here's the structure of my talk today. I want to start by saying a little bit about what this particular kind of climate engineering called solar radiation management is, for those of you who might not be familiar with it. Then I will sketch what I take to be the core argument in favor of doing research into solar radiation management. And then I'm going to walk through 4 main arguments against doing that research. Right, these are the trade-off, or so-called moral hazard argument, the slippery slope argument, the ungovernability argument, and the inherent immorality argument. And in walking through these, admittedly too briefly, given our time, I'm going to try to clarify what the argument is and why I think that even taken together, they aren't strong enough to overcome this core argument in favor of research. And at the very end, I'll try to draw out some lessons that we can learn from those 4 arguments, even if we don't think that they carry the day. So to get started, let's catch everyone up to speed by talking a little bit about what solar radiation management is. Solar radiation management, or SRM, includes any technique for cooling the Earth by reducing the amount of sunlight that gets absorbed by the land, the sea, or the atmosphere. You see some examples of proposals for doing this up at the top of this figure. They're the ones labeled in blue. A lot of the proposals would effectively make the Earth more reflective. For instance, by scattering tiny little aerosol particles into the upper atmosphere to reflect some sunlight back into space before it has a chance to warm things up down here. Along the same lines, we could spray tiny little particles of sea salt into the lower atmosphere over the oceans in order to whiten and brighten low-lying clouds. The more science fiction-y proposals would actually reduce the amount of sunlight that reaches the top of the atmosphere in the first place. So you could, for instance, scatter a fleet of tiny mirrors in orbit between the Earth and the sun. Down at the bottom of the figure, labeled in what shows up as a brownish red here, are some technologies that get called carbon dioxide removal. And they're often lumped together with SRM under the heading of climate engineering. I'm bringing them up only to say I'm not talking about those. I intend my remarks today to apply only to SRM. So what do you need to know about SRM and its effects? Well, first, you should know that it's reasonably clear that if it were deployed at a large scale, SRM could cool the planet. And so, in principle, it could be used to slow, reduce, or even reverse global warming and associated climatic changes. But it's also reasonably clear that SRM is a seriously imperfect way of offsetting a strengthened greenhouse effect, and that it has serious negative side effects. Perhaps most importantly, it is likely to have serious effects on global precipitation patterns, often in very negative ways. And so a high greenhouse gas world that is cooled by SRM does not have the same climate as a low greenhouse gas world without SRM. Which means that as a response to climate change, SRM is not a silver bullet. No matter what various headline writers would like you to believe, SRM is not a solution to climate change. However, as a supplement to aggressive, sustained mitigation and adaptation, right, as one part of a smart and well-balanced portfolio of climate policies, SRM might have the potential to reduce climate risk. And it might even have the potential to do that in a way that is quick, cost-effective, and morally acceptable. For instance, a gradual, modest, and temporary deployment of SRM over the course of several decades might be able to slow the rate of warming, which would be a big deal, or reduce the peak levels of warming, which would also be a big deal, as long as it's done in combination with aggressive mitigation. That's the kind of deployment that I have in mind today. That's the kind of deployment that a lot of researchers have in mind when they think about why it is they want to research SRM in the first place. So let's think about what that argument is. This is what I'm going to call the core argument for researching SRM. Pared down to its bare essentials, it looks like this. There's a serious risk that mitigation and adaptation efforts will not adequately reduce climate risk. Not that they couldn't, but that they won't. And let's be clear about something here. This is a sanitized academic way of saying that even with all of the things that people are doing to fight climate change, and even with the very real progress that we're starting to see in certain respects, there is still a significant chance that a lot of people are going to suffer and a lot of people are going to die because of climate change. That's what inadequate reduction of climate risk actually looks like. So the stakes here are high. This is a big deal. And you need to keep that in mind when you're evaluating the strength of this argument. Premise 2, SRM might have the potential, if used wisely, to reduce climate risk in a quick, cost-effective, and maybe even morally acceptable way. But notice all the qualifiers in there. Right? Solar radiation management might have the potential, if used wisely, to do all these things. The problem is that we don't know. We don't know if even a gradual, modest, and temporary deployment of SRM would actually meet these desiderata. Which leads me to the third premise of this argument. Making wise decisions about the use or non-use of SRM requires us to gather a lot more information than we have now. And that takes time. In other words, if we're going to make smart decisions about this, we need to know a lot more than we do. And if we're going to learn a lot more than we do, we need to do research, which takes a lot of time. Therefore, goes the argument, we should do further research into SRM. That's the argument in its bare form. A lot of people in the climate engineering research community find this argument quite compelling. In fact, some of them take it to show that we actually have an obligation to research SRM. I'm just going for the much weaker claim today that it is morally permissible to research SRM. I will admit, though, that this, along with sort of arguments about presumptions of scientific freedom, give us what philosophers would call a strong pro tanto reason to research SRM. A pro tanto reason you can think of roughly as a reason that can be overridden by other reasons. And so before we buy the conclusion of this argument, we need to look at what those other reasons might be. What are the arguments against researching SRM? And those are the four arguments that I said I was going to talk about. So let's get started on that by talking about the trade-off argument, or what is more commonly but less appropriately called the moral hazard argument. If you want to get a grip on the moral hazard argument, a good place to start is the racetrack. NASCAR spends a lot of effort making race cars safer. And in fact, they're so good at this that drivers can walk away more or less unscathed from some really horrifying crashes. Problem is the drivers know this. And so knowing that they are unlikely to be killed or maybe even seriously harmed in a crash, they're willing to take more risks than they did a few decades ago. And when you compound all of those drivers, taking all of those risks across all of those races, what you end up with is more accidents. Fewer deaths, but more accidents. And so it turns out that there's this trade-off between safer accidents and more accidents. Because the drivers are exhibiting a behavior that's known as risk compensation. When they're engaged in a risky activity, like making risky maneuvers on the racetrack, when the risk of that activity goes down, when they are protected against that risk, they're likely to do more of it, compensate for the change in risk. Now, a lot of commentators have long feared that even talking about SRM, much less engaging in serious research, will induce society to engage in similar kinds of risk compensation. Specifically, because emitting greenhouse gases is something we do in the process of activities that bring benefits. So you might think of emitting greenhouse gases as a beneficial activity, though indirectly. People are likely to do more of it when the risk from doing that goes down. And if you're doing more emitting, that means you're doing less mitigation. And so the fear is that there is a trade-off between mitigation and SRM research. Here's that argument in more detail. The expected level of mitigation effort is inversely related to the intensity of SRM research. Right, this is a fussy way, drawing on some sophisticated work by Christian Botts at the University of Kiel, of expressing the basic idea that the more people research SRM, the less mitigation we should expect. Right? That's the claim. That's what's being asserted in this premise in the argument. There's also a really important step here that usually just gets assumed. Within the expected range of mitigation, more mitigation is better than less mitigation, other things being equal. So it's not like we're going to be mitigating too much, goes the thought. And so if we reduce the amount of mitigation we're doing, that's a bad thing. From these two, it is inferred that SRM research will make things worse, with the problem intensifying as SRM research intensifies, and that therefore, we should not do further research into SRM. That's the argument. How convincing should we find it? Well, I think there are at least two serious problems with it. The first has to do with this first premise, that it turns out we aren't really sure how much of an effect there will be, or even if there will be one. Talk about that in a second. Second, subconclusion 3 here does not follow straightforwardly from the first two premises. So we'll talk about that too. Start up here. Why would we expect a trade-off? Well, on the one hand, we have some fairly heavy-duty theoretical reasons to think that there would be a trade-off. You have this basic decision theory of risk compensation, that as the prospect of SRM makes greenhouse gas emissions less dangerous, we're likely to do more of them. Second, there's the basic microeconomic point that mitigation and SRM are to some degree substitutes. They're both ways of buying a reduction in climate risk. Now, mitigation is by far the superior way, but it's also more expensive. And so just as you might expect, say, college students to spend some of their money on ramen noodles instead of better food because it's cheaper, you might expect a society to spend some of its climate change budget on SRM rather than mitigation. On top of that, you have a number of well-known psychological biases that are likely to make policymakers put more faith in SRM than they should, and so invest less in mitigation than they should. And when you put all these three things together, you have some solid reasons to expect that people would, in fact, reduce their mitigation efforts over the long run if they thought there was a serious prospect of deploying SRM. On the other side, however, you have a small handful of empirical studies that actually ask people what they would do. They provide people with some objective information about SRM, including its risks and potential benefits, and tries to gauge what they would do. And the surprising but consistent finding is that it doesn't actually reduce people's commitment to mitigation. In fact, at least in some people, it seems to make them more willing to mitigate, whether measured in expressed preferences or even in willingness to spend actual money buying carbon offset credits. The most popular interpretation of this finding is that people hear this information and they think, wow, climate change is so serious that people are thinking about doing that? Maybe we really do need to reduce our emissions. So maybe these studies are right. Maybe there won't actually be a trade-off. That would be nice, but I'm skeptical. Right? I'm skeptical that we can extrapolate from these fairly small studies looking at a relatively small number of Westerners in a low-stakes setting to what society as a whole would do in the very high-stakes game of global mitigation policy. I'll admit, though, that that's uncertain. And I think that's, in fact, where we're left with this first premise, deeply uncertain, in the technical sense of deep uncertainty, about the size of this trade-off, in fact, even the sign of the risk compensation effect. That doesn't mean that premise one is definitely false, but it definitely weakens the argument and it weakens the amount of support it can lend to this conclusion. Let's look at the problem with moving from premises 1 and 2 to subconclusion 3. This problem comes from that little clause right there, other things being equal. Right? That clause doesn't show up in subconclusion 3. Right? 3 is not about SRM making things worse, other things being equal. It's about making things worse, full stop, all things considered. Right? And you can't get from other things being equal to all things considered here, because once SRM is on the table, other things are not equal. And in particular, you can't necessarily say, given what we know now, that a world with less mitigation but some SRM is going to be worse than a world with no SRM but more mitigation. Right, so in order to get to this subconclusion 3, we would need to know what the trade-off is between SRM research and mitigation. We would need to know what the effects, positive and negative, would be of SRM. And we would need to know how to compare that lower mitigation world with SRM to a higher mitigation world without SRM. And we don't know any of those things right now. We're deeply uncertain about all of those things. And so here, too, we have deep uncertainty about this move from 1 and 2 to 3. And so this argument is, I think, mired in layer on layer of deep uncertainty, and thus cannot provide a particularly strong reason to think that the core argument in favor of SRM research fails. So maybe we should look for a different argument. Let's turn to the second oldest argument against SRM research, which is the slippery slope argument. I like to introduce this argument with a joke from the writer James Thurber, who says, 1 martini is all right. 2 martinis are too many, but 3 martinis are too few. Right? And the idea is that if you've already had 2 martinis, you shouldn't have another, not because there's anything wrong with that 3rd martini in itself, but because once you have that 3rd martini, a 4th or a 5th or a 6th is going to seem like a fantastic idea, and next thing you know, you're waking up in some strange place with a splitting headache, wondering what happened. Now, I like this example because it nicely illustrates all 3 things that you need for a good slippery slope argument. First, you need a bright line that should not be crossed. In this case, that 3rd martini. Second, you need an uncontroversially bad outcome. In this case, the hangover. Third, and most importantly, you need a plausible and relatively well-defined mechanism by which crossing that bright line will carry you with certainty or high probability to that undesirable outcome. If you don't have all 3 of those things, what you have is a slippery slope fallacy, not a good slippery slope argument. So let's see how this applies to SRM in particular. Pared down to the bare bones, the argument looks like this. If some kinds of further SRM research are done, they will lead to some kind of deployment that would be very bad. And that, therefore, those kinds of further SRM research should not be done. But this has to be filled in with the 3 things that I just talked about. For instance, you need to specify which research we're talking about. What kinds of research put us on this slippery slope? You need to say what kind of deployment you have in mind that would be very bad. And most importantly, you need to specify how one thing will lead to the other. What are the mechanisms by which doing this research will lead us with certainty or high probability to those kinds of undesirable deployment? I'm going to focus just on this last question and just on 2 particular mechanisms because I think they're the most important in this discussion. The first mechanism has to do with what people call vested interests. The thought here is that once serious research into SRM got going, there would be certain groups of people who have a strong interest in pushing it further, or at least in keeping it going, and that those special interests might push for more research even if that turned out to be a bad idea. A lot of people like to bring up academics or bureaucrats, motivated by what Jane Long likes to call fame, fortune, or fanaticism. And I think there's something to that. I think academics and bureaucrats might be motivated to keep pushing for more research, but I also think their power would be pretty limited here. So more concerning to me are commercial interests. These include not just commercial interest firms who might have a direct stake in supplying or delivering SRM services, which turns out to be relatively cheap and so not a huge moneymaker, but also in commercial interests that have a stake in seeing SRM deployed or in the prospect of its being deployed. For instance, large agricultural firms, giant agribusinesses, might have a motivation or a financial stake in seeing SRM deployed because it would protect the climate in the areas where they actually own land. Fossil fuel companies might have an interest in the prospect of its being deployed because they could use that prospect to push back against mitigation efforts. Right, so here we see the connection between the slippery slope argument and the moral hazard argument. That connection goes a bit deeper, too. The second mechanism I want to discuss for a slippery slope is that if there is a trade-off between SRM research and mitigation, and we reduce our mitigation efforts because we think we might be able to use SRM, we might eventually find ourselves in a position where SRM actually becomes more desirable because we haven't mitigated enough, even though we could have avoided that bad situation by just mitigating in the first place. Of course, these things can operate in tandem. If you have, say, fossil fuel companies that push back against mitigation so we don't mitigate enough, and then we find ourselves in a position where it seems reasonable to deploy SRM, that would be both of those things pushing us down the slippery slope. But the connection to moral hazard, to the trade-off argument, suggests that there's some deep uncertainty here as well about the strength of this effect. And I'm a bit skeptical that the strength of that effect would be enough to push us all the way from research to deployment. In particular, I'm skeptical that it would get us over what I think is a big gap in practice between the kinds of research people are talking about doing in the, say, next decade and a global field trial of SRM, which would be a sort of quantum leap in the kind of research you're doing and the effects that it would have. So I guess I want to say the same thing about this argument that I did about the trade-off argument, that there is just too much deep uncertainty here to think that this gives us a really strong reason to avoid further research into SRM. And that's even without considering problems with the other two questions here. So maybe we should try a very different kind of approach to arguing against SRM research. These last two arguments focused on what you might think of as the undesirable consequences of doing the research itself. This next argument, as well as the one that follows it, takes a different approach. Both of these arguments will essentially say, look, we already know now that we should never use SRM. And so there's no point, at best, in bringing this dangerous technology into existence. First of these arguments, the ungovernability argument, says that we know we'll never want to use it because we know now that we will never be able to govern it wisely. Global society will never be able to govern SRM effectively and legitimately. That's the key claim in the ungovernability argument. Now, the best version of this argument that I know of comes from Mike Hulme at King's College London, and it goes more or less like this. SRM deployment would have to be governed either by the UN, by a coalition of states, or by a single state acting unilaterally. Right? That's just supposed to be kind of carving up the logical space. Those are the options. 2, the UN could not effectively govern SRM because it could never agree on deployment. It could never agree how or when to use SRM. So Hulme says, any effective coalition, that is a coalition of multiple states, would be illegitimate. You might think that some coalitions would be big enough to be legitimate, but then they couldn't agree either. Or you might think that some coalitions are small enough to be effective at making decisions about SRM, but that those wouldn't be politically legitimate. They wouldn't have the rightful authority to make that sort of decision. Finally, unilateral deployment would be illegitimate. That is, this kind of globe or planet-altering technology isn't something that a single state could deploy on its own. And so, no governance regime could be both effective and legitimate. That's the argument. I think of all four arguments I'm looking at today against climate engineering, I think this one's actually the strongest. For me, I think the real fear about SRM is that it would be used unjustly. But if there is a weakness in this argument, and I think there might be, it's going to be in premise 2, or more likely, premise 3. So premise 2 strikes me as plausible but not definite. This is firmly outside my area of expertise, so I will not speculate on it, especially here at the School of International Service. But I will say something about premise 3. In particular, I want to say something about the claim that a coalition of states would necessarily be illegitimate. I think we have only a vague idea about what global political legitimacy looks like. That is, about what it takes for a global governance body to have the authority to make certain decisions. But the simplest model just extends our sort of common representative democracy model from the domestic level to the global level. But there are some reasons to think that that might be neither necessary nor sufficient for global political legitimacy. And so it might be possible, I would argue, in principle at least, for a coalition of states to build a globally politically legitimate governance regime for SRM. I say in principle because I'm a bit skeptical about this in practice. And here's the argument for that in sort of abbreviated form. A legitimate governance regime for SRM would have to make these decisions in a way that is just and a way that takes everyone's interests into account. And if you have paid any attention to international politics in the last 10,000 years, you will know that that is not always the case. And it's quite likely that these sorts of decisions would be made based on geopolitical factors that will not take everyone's interests into account. But there are still some important open questions that would need to be answered before I think we can be sure that premise 3 is correct. In particular, we'd need to know how difficult it would actually be to design an SRM deployment that not only protects the interests of whoever the coalition members happen to be, but also respects the interests of the non-members. That's mostly a climate science and engineering question. And of course, there'd be some questions about how you define the coalitions, which are not scientific questions. There's also a question about what the mechanisms could be that might induce the coalition members to respect the non-members' preferences. That's a question of politics and political economy. So the ungovernability argument raises some important research questions about how you might design SRM and how you might design an SRM governance system. It raises some important research questions about global political legitimacy, but it doesn't shut them down. It doesn't yet give us a reason to think that we should not be doing any more research. Because it seems to me we do not yet know that SRM would be ungovernable. Well, let's try one more thing. An argument, or better, a family of arguments that I'm calling the inherent immorality argument. This family of arguments all has the same underlying structure, and it looks like this. We know now that deploying SRM would be inherently immoral. We shouldn't even bother to investigate doing something that we know would be immoral, and so we should not research SRM. Now, when I say in articulating this argument that SRM would be inherently immoral, I mean that there is no way of deploying it that would be morally acceptable. Right? That's what I take that premise to mean. to get a better grip on that, consider the following. We, I hope, would all agree that there are some ways of deploying SRM that would be morally wrong. So, for instance, if a single country unilaterally decided to deploy SRM in a really intense way, and this had serious negative consequences on billions of people, including the poorest and most vulnerable, that would be wrong. But a lot of people who research SRM hope that there could be a different way of deploying SRM. Maybe the modest, gradual, temporary kind of deployment I discussed earlier that would bring a net reduction in climate risk, and that the benefits of that deployment would be fairly distributed, and that this seems like it would make the world a better place. What this first premise is saying is that even that kind of deployment would be wrong. Why would you think that? That's the key question here. Why think that SRM deployment is inherently immoral? Well, there are a bunch of different reasons that people give. I want to talk about just two of them as sort of examples. First, you might think that deploying SRM manifests a kind of hubris, a kind of arrogance. In particular, that it displays an arrogance in refusing to recognize the limits of our power and our knowledge, in refusing to recognize the limits of what we should try to do in the world, or in refusing to recognize our place in the world. For that reason, people often describe this argument as the playing God argument. Right? People sometimes think that trying to control the climate like this is playing God in an objectionable way. Furthermore, you might think that there's a risk in displaying this hubris, in trying to play God, that we're inviting catastrophe, that things will go horribly wrong, this technology will get out of our control, perhaps in ways that we just don't expect. So for that reason, some people think it's inherently immoral. A second reason, some people think that SRM would violate a moral principle against large-scale human interference in the natural world. Or to put that same thought a slightly different way, it violates the principle that we should live in harmony with nature, which is something that lots of people and lots of cultures value quite highly. There's some sort of obvious replies to this line of argument, perhaps most obviously that human-caused climate change is already a massive interference in the natural world. If you're interested in that line of argument, I'm just going to refer you to the work of the environmental ethicist Christopher Preston at the University of Montana. He can address that much more elegantly than I can. There are a number of other things you might say here, but I don't think we actually have to walk through all of them, because I think there's something we can say about this kind of argument in general, without having to look at each variation. But to see how that works, we need to draw one distinction, and we need to delve a little bit into political philosophy. So the distinction is between two different senses of my title question today. Is it morally permissible to research SRM? That might mean, is it morally permissible for private entities to conduct SRM research or to fund SRM research? The flip side of that is it permissible for governments to ban such research by private entities? The second interpretation of my title question is it permissible for public entities, say government agencies, to fund or conduct SRM research? That distinction matters because I think most, maybe all of the inherent immorality arguments rely on highly controversial moral premises, and in particular premises about our, that is, people's proper place in the world. These are what political philosophers would call a thick conception of the good life. And on many views in political philosophy, coercion by the state, for instance, a ban on private entities conducting this research, requires public justification, that is, justification expressed in reasons that the people being coerced could accept themselves. And in general, thick conceptions of the good life do not count as public justifications, because resting on controversial moral premises about how we should live, they're not going to be accepted or acceptable to all of the people being coerced, in this case, the researchers themselves. This is often expressed in political philosophy with what's called the public justification principle. Public coercion requires public justification, and controversial moral premises don't count as public justification. That's the nutshell version of the argument. So, the inherent immorality argument, I'm suggesting, can't be used to justify a public ban on private entities conducting SRM research. When it comes to public entities, I'm a bit less sure what to say. I'm inclined to say, though, that government agencies shouldn't be using these controversial moral premises in their own reasoning either. And so in the absence of a legal directive, say from Congress, telling them not to engage in such research, it is permissible for government agencies to fund or conduct SRM research. I don't know what to say about the wisdom or justifiability of a law prohibiting public agencies from conducting such research, but I think the point at which these inherent immorality arguments would enter into that discussion is in private citizens deciding whether to support or oppose such a law. I am sort of relieved of the task of trying to figure out what such a law would mean for the justifiability of climate engineering by the fact that there is no such law currently, and governments have not yet taken a serious enough look at this to make a decision. So when you put those two sub-conclusions together, you get the result that I don't think this inherent immorality argument can be used to justify a ban on private entities doing public research, or, at least at the moment, on public entities conducting or funding such research. And so we've now gone through all four arguments, and I've at least explained why I think that each of them suffers from very important weaknesses. However, what that gives us is what informal logicians call a conductive argument, where you have a bunch of independent arguments providing support or opposition to a single conclusion. And unfortunately, there's no algorithm or no quantitative method for sort of weighing these arguments up and deciding how to balance them. We're left just having to make an intuitive judgment about where the strength of reasons or the balance of reasons lies. And it seems to me, for the reasons you've heard today, that the arguments against SRM research do not outweigh the core argument for it. And so, it seems to me, further research into SRM, including limited outdoor research, is morally permissible. Right? By limited outdoor research, I mean to exclude things like a global field trial of stratospheric sulfate aerosols. That said, I think there are some important lessons that we can draw from considering the four arguments I've looked at. So let me briefly sketch those. I think they remind us that when we are thinking about SRM and SRM governance, we should focus on certain kinds of deployment. It really matters whether you are talking about undoing all human-caused global warming for the indefinite future, right, which would mean for hundreds of years, or if you're talking about a gradual, modest, and temporary deployment to slow the rate of warming. Those are two very different things. The ethical questions, the governance questions are going to look very different. Second, I think we can and should take steps to reduce trade-offs between SRM research and mitigation. And we can take steps at both an institutional and an individual level. The most well-known institutional response, for instance, is to link participation in SRM governance at the international level to adequate mitigation efforts, so that countries that aren't mitigating properly are excluded from decision-making about SRM deployment. At an individual level, that is the level of researchers, we can think hard about how we research SRM, how we communicate that research. For instance, you can embed the following kinds of sentences in your talk. SRM is not a silver bullet. SRM is not a solution to climate change. SRM is at best a supplement to sustained aggressive mitigation and adaptation. Did I mention that? Good. Good. What other lessons can we draw? If we're worried about commercial interests in the slippery slope, we can take steps to make regulatory capture difficult. Right? Regulatory capture is when some special interests essentially captures control, gains control over regulation of a particular issue. So this was the worry about, say, commercial interests pushing for more and more research. How would we do this? There are various things that have been suggested. We could structure rules and norms around intellectual property to minimize profit motives for supplying SRM services. We could structure governance, say, across institutional or international lines to increase the number and diversity of regulators who would have to be captured. Right? It's a lot harder to control regulators in the United States, Germany, and China than it is to control some one office in the executive branch of the American government, for instance. That also relates to political legitimacy and international governance. As well as learning how to use or how we could use SRM, we need to start thinking now about how we would govern it. And so we should begin building in international governance early in the research governance stage and not wait for that further down the line. These steps, I think, will help, but they're not a panacea, they're not a guarantee that things will not go badly. In other words, we need to remember that when we're thinking about SRM, we're playing with fire. And if things go badly, we are not the only ones who will get burned. And so if we choose to go down this path, we have an obligation to make sure that we get things right. Which is why I'm looking forward to our discussion when you can tell me where you think I have failed to do that. Thank you very much for your attention. The question, if I understand it, is about how that clause about limited outdoor research gets into that conclusion. And I heard at least two parts to that. Why don't you draw the line, why don't I draw the line below outdoor research, so say no outdoor research, and why do I draw the line there rather than, say, at global field trials? That's a great question. The reason not to draw the line below outdoor research, that is the reason I include outdoor research as permissible, is that I think the main reasons not to do outdoor research are related to the slippery slope argument and the trade-off argument. So the thought is that the line between a lab and outdoors is this nice sort of bright line, right? It's at least as bright as that third martini. And so that's a convenient place if we're worried about going too far in the research. But if, as I think, the slope is not actually all that slippery, then we don't need to draw the line there. In other words, there's no reason, if you don't buy those four arguments, to think that there's a special problem with outdoor research. I should clarify, though, for those who sort of aren't that involved in this discussion, what kinds of things would count as limited outdoor research, right? What are people interested in doing? Some examples. You could take a plane that has the particular kinds of aerosols that you want, or aerosol precursor chemicals, up into the lower stratosphere and release them behind you. And then you fly the plane back through that plume of aerosols to take measurements, to see what those particles are doing. This would have no direct environmental impacts. Right? It's a trivial amount of aerosols. But it could help answer some really important questions about SRM. For instance, one of the big outstanding sort of technical questions is what's called the particle size question. So you need to understand exactly how big the particles would be with different ways of dispersing them because the size of the particle makes a huge difference to how much light it scatters, the direction of the scatter, and how long it stays up in the stratosphere. Right, so that's a big, important question about the effectiveness of SRM. And so the physicists tell me, we can't answer that question without putting a plane up there. Another example would be going out on the ocean and just spraying some salt up in the air and seeing if it actually gets up to the clouds. So you could just run a ship back and forth through the Pacific for a while and track it by satellite and see what it does. Right? And this would be no more damaging to the environment, maybe less so, than just a normal cargo ship that's taking stuff from China to the US. In fact, you can see ship tracks of just this sort on satellite images. That's sort of what gave people the idea they could do this. So those sorts of things have no direct environmental impact. The only reason to worry about them is if you think that they put us on this slippery slope, or if you think that once we do that, people are going to say, aha, we've got this silver bullet. Right? Did I mention that SRM's not a silver bullet? Good. But they might think that we've got this method, and then they'll want to reduce mitigation efforts. Right? So those are the arguments against limited outdoor research. I don't think they apply, and that's why I include that in there. It's a great question. The global field trials, though, those are really dangerous. It is effectively experimenting on everyone. As far as I know, everyone in the climate engineering community right now thinks that we shouldn't be doing those, we shouldn't be planning them. Maybe at some point in the future, depending on how the other research turns out, we'll think about it, but not yet. The question is why I think that premise 2 here might be false. That is why I think that the UN might be able to govern SRM effectively. So I have sort of two things to say here. The first is to reiterate that international politics is not my area of expertise. Right? I can talk about normative things much more happily, like political legitimacy. And so in some sense, it's just beyond my expertise to know whether this is true. The second thing I want to say, though, is that I've taken this formulation of the argument more or less from a book by Mike Hulme called Can Science Fix Climate Change? And the answer to that is no. Well, in the sense that he means the question anyway. And in that book, he gives an argument for premise 2, and I don't buy the argument. And his argument is roughly this. Look, the most ambitious attempt by the UN to govern a climate issue is the UN Framework Convention on Climate Change. And so far, maybe in 2 months we'll have a different view of this, right? But so far it hasn't been astonishingly successful, shall we say. And so, Hulme says, we shouldn't expect a similar UN attempt at governing SRM to be successful. Here's why I don't buy that argument. The problem structure of mitigation and SRM are very different. Mitigation policy is a free rider problem. Right? Mitigation is expensive. It depends on everybody cooperating. And so each country has an incentive to free ride on the other country's mitigation efforts, to let everyone else do the work. Right? SRM is what the economist Marty Weitzman famously calls a free driver problem. So one country could decide on its own, right, that it's in a sort of technical level, what amount of SRM to deploy. And if, say, the United States deployed a certain intensity of SRM and, say, India said, no, we want more, well, India can just push a little harder on the gas pedal, as it were, and they drive a little faster. You get more SRM. And so it's not a matter of getting everyone to take these painful steps the way the Framework Convention is. It's a matter of at least getting people to agree on someone or some group of countries taking a particular step. So that's why I don't buy Hulme's argument for it, and why I think there at least might be a hope that the UN could govern it effectively. The question is whether SRM would, or whether it's possible for SRM to just impact one country or region, or whether it will necessarily cross borders. Short answer is it will necessarily cross borders. Most likely, it is necessarily global in scope. If not quite global, at least you would have very, very different effects in widely varying places. There's some people who think that you could, say, do just Arctic SRM that would affect countries around the Arctic. It's unclear to me whether that's actually possible. And I know there are some results suggesting that, say, Northern Hemisphere SRM would actually have serious repercussions in the Southern Hemisphere. Right? So even if you tried to contain it in one half of the globe, you would still have effects on the other half. So that is certainly one thing that makes it both ethically and politically a difficult issue. The question is about what legal obstacles there would be to... well, so that's an interestingly different question about geopolitical obstacles. So we'll talk about both of them, right? And of course, in talking about legal or geopolitical stuff, we are again outside my area of expertise. But I can tell you what people who are experts in those things have told me about this. In terms of legal obstacles, it seems to be that at the moment, there probably are none. At the moment, it's just unclear whether any laws, that is, any international laws, could be applied to SRM deployment, either from a particular country's territory or on the high seas. There's some speculation that the Long-Range Transport of Airborne Pollution Treaty might be able to apply in some circumstances, but other people say no. A few people say the NMOD Convention against environmental modification for hostile purposes would apply, but it seems to be in most cases that would not be the case, and most of the legal scholars I've talked to say the same thing. In terms of geopolitical obstacles, though, well, it depends, right? It depends on who's doing it and what various other countries expect to happen. So on the one hand, one sort of nightmare scenario that people bring up is the worry that certain kinds of SRM could have a serious negative impact on Indian Ocean monsoons. And that's a big, big deal because there are hundreds of millions of people who depend on those monsoons for agriculture. So if, say, some small island nation decided that it wanted to start testing SRM because it hoped that that might prevent some sea level rise, and India decided they didn't like it, well, then as when any large power doesn't like something that someone else is doing, they can bring various forms of leverage to bear. Some scholars, notably Josh Horton, who is now at Harvard, have argued that because of those kinds of concerns, unilateral deployment is actually very, very unlikely. So this has often been one of the big worries, that a single rogue nation could just deploy SRM. Horton argues that because of geopolitical responses, that's actually not very likely. I don't know what to think of his argument on that, but again, that's outside my area of expertise. We think about it by limiting ourselves to limited outdoor research. Here's why. If we were going to make a decision about deployment or a global field trial, let's talk a little bit about that. A global field trial is essentially low-level deployment for a long time. That's what it would take to detect a signal in the noise of normal climate fluctuations. Right, so people like to say you can't test it except by doing it. That's not quite true, but just as with, say, testing a pharmaceutical, you've got to give it to people eventually to see if it works. A global field trial would mean doing it at a relatively low dose, but for a pretty long period of time. If we got to that point, where I'm not sure who we would be at that point, right? But someone is making that decision. That's the point at which I think it would be problematic to say, no, you're not allowed to use your argument about hubris. For exactly the reason you suggest. If we say you're not allowed to do that, we're ruling you out of this political decision. So one way to think about what makes a decision political in a sort of normative sense is that you're trying to make a decision in which you have competing controversial values, but you can't satisfy everybody's or honor everybody's values in doing that. And so I agree that we wouldn't want to just rule out these controversial things at that stage. But when we're doing limited outdoor research, we're not making that kind of social choice where we are deciding for everybody whether to become the kind of species that tries to control the climate. Right? We are just making these much more limited and in some sense more private decisions about doing this or that kind of research. Now, that claim, as well as my claims about the ungovernability thesis, by the way, depend on the rejection of this slippery slope argument. If you think, as Mike Hulme does, and I don't, that the slope really is slippery from research to deployment, then the mere possibility that SRM is ungovernable, or the possibility that enough people will think it's inherently immoral, tells you you shouldn't even get on that slope, because there's too much of a chance that it will take you somewhere that we don't want to be. Right? Even if that's actually controversial whether we want to be there, right? You don't want to make that decision in advance. So my arguments against that depend on my rejection of the slippery slope argument, which to some extent, you may have noticed, depends on my rejection of the trade-off argument. So all of these things turn out to be interlinked. The question is, if we could predict now that once SRM is developed, if it were ever developed, people still wouldn't want to use it because they accept this sort of hubris argument, then we shouldn't bother to develop it. Right? Yeah, great question. I think it's actually an even more complicated question than you might realize, or maybe you do realize this and just let me walk into it. But it's complicated for several reasons. One, it's of course hard to predict right now what people will think, partly because this presumably wouldn't be deployed for several decades, and people might have very different views. Right? If you're making decisions, say, in the early 50s about nuclear power, and you had no idea the environmental movement was coming, right, you would be quite surprised at how people felt several decades later. But to make this a bit more sort of insidious, the decisions we make now about whether to develop the capacity for SRM might affect people's views in the future about whether it's hubristic, right? Or in general, what their preferences are with respect to it. And this, I think, is something that's really hard to think about what we want to do. On the one hand, it's not like we can avoid influencing people's preferences in the future. Right? Whatever we do, it's going to have some kind of effect on them. It's also unclear, to me anyway, what we should say if we think that I would prefer that society not do X today. I know that if I do Y today, then in the future, people will prefer to do X. In other words, if I do action Y, I will effectively cause people in the future to want something that I wouldn't want today. Well, is that a reason for me not to do Y? In some cases, yes. If there were like something I could do that would make other people prefer enslaving people in the future, I should not do that. Right? That's a really good reason not to do it, because I think that preference would not be acceptable. Right? I have reason to keep people from forming that preference. If it's a matter of my doing something today that will cause people in the future to prefer Chicago-style pizza over New York-style pizza. I don't know. Right? Does it matter whether I shape that preference? Right? I will withhold my view about which of those is obviously correct. So I think there are two very difficult things there. One, it's really hard to predict what people will think. And two, it's hard to know what to say about the fact that there are these sort of dynamic preferences, and our choices today will affect what preferences they have in the future. So that's definitely an important twist on several of these arguments. The question is about the different kinds of risks and objections to nuclear power on the one hand and SRM on the other. So I take it in the case of nuclear power, there are two main kinds of objections. The one you mentioned was the problem of storing nuclear waste, which is a very, 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 very long-term problem. The other worry is a more localized worry about the risks of, say, a meltdown at the plant, right, which would affect people and ecosystems around the plant. The long-term worry about storage has an analog in SRM if you are thinking about indefinite deployment. So if you said, here's what we should use SRM for, we are just going to keep temperature increases to 2 degrees forever, and we're just going to keep burning carbon. Right? So we'll make no mitigation efforts. We don't need to worry about that, some people might say. We're just going to use SRM to keep the planet from getting any warmer than we're willing to accept. Because carbon stays in the atmosphere for decades to hundreds of years to thousands of years, right? That means that you would have to deploy SRM for centuries. Right? Otherwise, when you turn it off, all that warming comes back. And so one kind of worry about radioactive waste is that you get these intergenerational problems, that we're making decisions today that impose risks on people very far into the future, and that you might think is unfair. If you were to use SRM in this essentially permanent way, that would also impose risks on people in the future. And if you keep burning carbon, those risks just get greater and greater and greater because you have to keep doing more and more and more SRM. And so that creates this sort of intergenerational injustice. The second worry about a meltdown at a particular plant is, I think, very different in structure because it's a local worry. It's the kind of thing where people might say, oh, I am all for a nuclear power plant over there, far away from me on the other side of my city. With SRM, you don't get that because it's global in nature. You can perhaps modify SRM so that the effects in a particular area are greater or less in a particular dimension. But it's still essentially a global technology, and so that kind of risk is different. Does that answer your question, or were there any other risks that you had in mind? Okay, good. Simon? 6 years? So the question is why I am now advocating for a particular stance on research, and in essence advocating certain kinds of research, and what the fact that I'm doing this now rather than earlier or later tells us about the state of the conversation. Yes, you're reading my talk correctly that I take myself to be doing something I haven't done before. Other people think that I have said in the past that we should research SRM or that we shouldn't research SRM. But all I've actually said before is, if you accept this set of premises, then you shouldn't research SRM. If you accept that set of premises, then you should research it. And now what I'm telling you is, these are the premises that I accept, and on that basis, I think we should research it. Why am I doing this now? In part because I think I've thought through enough of the arguments to satisfy myself that I am now prepared to come out on one side of the issue or the other. But it's also because I think we are getting closer to the point where, say, foundations or large universities or maybe even public entities will actually start making decisions about whether to fund outdoor research. And so it's worth saying something about what I actually think about that issue. Yeah, so that's the line of thinking that has led people from some early conversations where people thought, well, maybe we really could turn down the global thermostat a lot and permanently, to where people are now, where they say, well, maybe we can use this to change the path of global temperature a little bit. Because, yes, if you keep pumping carbon into the atmosphere, and you want to either flatten temperature or reduce temperature change, you'll need to keep pumping more and more, say, aerosols into the stratosphere. On a technical point, the kinds of aerosols that people are thinking about putting into the stratosphere would stay up there for about 2 years. So you would need to do this, on a fairly constant basis. And in fact, that's not a trivial engineering challenge, right? Getting enough stuff up there. There has been, I believe, some exploration of what the sort of maximum amount of cooling you could get would be with various methods. And part of that does depend on just physical stuff about how much sulfate you can put up into the stratosphere before it coagulates and falls out. I can't tell you the details of it, but what I recall from what I've been told by the people who do know the details is that you could probably get more cooling than it would be a good idea to do, in the sense that getting that much cooling would have unacceptable side effects. Right, so on the one hand, we could do it. On the other hand, we couldn't do it indefinitely, but we don't want to do it indefinitely anyway. No matter what I say, some climate scientist is going to be mad at me. How shall I put this? Not so confident that you should bet your life on it, which is a problem, because that's what we're doing. Right? Yeah. And a lot of this depends on the details of various climate models. So some models try to model what's going on by turning down the sun in the model. Right? So you just change a number in the model about how much energy comes in from up above. And of course, on a physical level, that's not what's happening. I mean, it is with like space mirrors, but most people aren't taking that all that seriously right now. And so it really is sort of a novel climate. It's one that we don't have a lot of experience with. And so there's a reason for some doubts about the accuracy of the models. On the other hand, one important analog for the stratospheric aerosols is volcanic eruptions. And those actually inject a whole lot of sulfates into the stratosphere, and you can see what happens. And Alan Robach at Rutgers has an increasingly detailed argument that when you look at the history of large volcanic eruptions, you not only see significant cooling, you see major disruptions to climate. In fact, there was just a paper last week that suggested that major volcanic eruptions reduce river flows, perhaps by up to 10%, which could be a big deal. So the climate models tell us a lot. We shouldn't be, we have some reasons to question how accurate they are. We have some physical analogs This is one reason you would want to do a long, low-level global field trial. The sort of obvious analog there is that if you are testing a pharmaceutical, you don't just give it to people at full doses, right? You build up slowly and you're watching for negative side effects. Right? So yes, the gist of Jordan's question for, if you couldn't hear it on the, or his response, if you couldn't hear it on the video, is that we don't know exactly, but that's why people want to do this kind of research and gradual research to answer some of those very important questions. Thanks for your attention.